Hello, Kylie. Here's the question that I think you're referring to as number 6 on the binomial distribution assignment. So I've started us off with the information from the question. We have 8% of the computer chips are flawed. So P is going to be 0.08 because that's the probability of them being flawed, which in this case is our probability of success, which I know sounds backwards, but that's how it works. Q is the complement of that, in other words, the number that adds up with 0.08 to make 1 exactly, and so Q has to be 0.92. So to start off with the probability that we get 0 flawed computer chips, we would be taking 5 and trying to choose 0 that are flawed, which would mean that 0 is the exponent on the P value, and 5 is the exponent on the Q value. And so if we work all that out, then we just end up with 1 times 1, because 5 choose 0 is 1, 0.08 to the exponent 0 is 1, and then that's times 0.92 to the exponent 5. So if you work that out, that's why we get such a big value for the 0, for the probability of having 0 flawed chips. Rounded off, that's 0.66, so a 66% chance, and if you look at the graph, that's exactly what we've got graphed there, okay? So as we carry on, what we're going to do is we're just going to change the X value for the number of chips that we want to find flawed. And so I'll just start you off for the next one, for X equals 1, and here's what it would look like. We have 5 chips, we want to choose 1 of them to be flawed, and so the percentage of the flawed, which is the 8%, should have the exponent of 1, and the percentage of the not flawed chips, that we should have 4 of those, so that's 0.92 to the exponent 4. And so if you work this out on your calculator, you'll end up with a slightly smaller number in terms of a percent of having 1 flawed. That's about 0.29 rounded off to 2 decimal places. And so again, if you look at your histogram and the solutions, then you're almost at 0.3 but not quite. And so that's why that happens. So just carry on doing these types of calculations with the different probabilities. We want X equals 2, 3, 4, and 5, and so on. And that's how we construct the histogram when we're calculating it all by hand.